Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania.
The next number is 129. The next number is what? 378. The next number is what? 99,978. The next number is 2022. 2022. Then the next number is 74,592. Then the next number, etc. Wonderful. So now you're not limited to see the radix, because I know that myself, I was surprised. I expected from the day I learned about decimal number system, whenever I see any decimal number system in the context of number system, I expected to see the radix at the subscript. But wonderfully enough, it wasn't like that. In most cases, I found the decimal number system or decimal numbers have been written without the radix. So that's why I want to let you know and be aware of that, and don't be confused with such kind of the situation. You have to crack it and stay at the top. That's very important concept. Okay, so in basic mathematics for the Form 1, we taught you about numbers, and then we taught you about the value of a number sometimes depends on the position. How about the decimal number system that we are talking about here? It's the same. It's the same. It means the same definition, so it's the same concept that we are using. The position of the value of a number is determined, or the value of a digit is determined according to its position in the given decimal number system. Okay? Then afterward I will talk about most significant figure and least significant figure. Then from there we'll be just diving into the binary number system. Well, so now let me take you into the diving into the first concept, which is position of a digit in decimal number. That's what I want to talk. Once I'm done with this, I will teach about significance, the most significant number and the least significant number. That's how we call them, the most significant digit and the least significant digit. Later on we have most significant bit and least significant bit. Very important terminologies because we'll encounter them in lecture 2. This is the second lecture. Lecture 1 is lecture 0, General Introductions of Boolean Algebra, and this is lecture 1, which is second lecture. But just in naming, it's lecture 1 because, you know, we as digital electronics engineers, we appreciate number 0. You see 0 and 1? So we always counting from 0. We're always counting in terms of binary. So that's why that in all my lectures, in all of my sessions in TOASO, in Umutom, in KCTOM, all of those are online schools that by grace of God I've established them in Optom. So You find those are the abbreviations of our online schools. So we are using lecture 0 and we are using also session 0, right? Because by God's grace, He has given us an assignment to feed through teaching God's students from Form 1, Form 2, Form 3, Form 4, Form 5, Form 6, first year of ordinary diploma in engineering and science, second year of ordinary diploma in engineering and science, third year in ordinary diploma of engineering and science, and also we have an assignment to teach first year undergraduate engineers and scientists, and second year undergraduate engineers and scientists, and third year undergraduate and undergraduate engineers and scientists, and fourth year undergraduate engineers and statistics. So how many classes? Okay, for secondary education, 6 classes. For ordinary diploma, 3 classes, or 3 levels of study. It means 3 classes, so make 9. And then for undergraduate or bachelor degree, we have 4 classes. So 4 years of study, right? Because each class is 1 year of study. So total makes how many? We have an assignment to incubate 13 classes. Wonderful. This is for God's glory. It's not for me because I'm very intelligent or I know so much. I just know small portions of it, but I have a responsibility to teach others what I know. Wonderful. So give all the glory and honor to my living God who is teaching you in me right now. Right? So position of a digit in decimal number. So the decimal number system, is positional, okay, is a positional number system. So decimal number system is a positional number system. Is a positional number system. What does it mean? The value of a digit depends on its position. The value of any digit, in decimal number, the value of any digit in decimal number depend on what? Depend on the position the digit occupies. The digit occupies. So the value of any digit in decimal number depends on the position the digit occupies. What does it mean? If you remember what we taught you in numbers at the first topic in basic mathematics for the Form 1, we taught you about this concept. When we've been teaching about whole and natural numbers. So let me give you a simple example that can help you understand. Example. You can have a decimal number of this value. 7,693,475. Let's say this is base 10. So here we have how many digits? First digit, second digit, third digit, fourth digit, fifth digit, 6 digits, 7 digits. So you can count first digit, second digit, third digit, fourth digit, fifth digit, seventh digit, now 6 digits, 7 digit. Alright? So this we call it ones, tens, thousands, hundreds, thousands, 10,000s, 100,000s, million. That's what we taught you in form. So now our focus is we have a digit with a value of 7. We have 2 sevens. So now the questions come in the mind of mathematicians. Do these sevens have the same value? The answer is no. Why? Because the position of this 7 is not the same with the positions of these 7. These 7s is located in positions of tens, and these 7s is located in positions of millions. Wonderful. So this is 7 million, this is 70 something. Right? Okay. So the 2 sevens in example above don't have the same value. 2 7 don't have the same value. Why? Because the first 7 stand in the millions, the positions of millions, and the other 7 stand in the positions of 40 of ones. Then we say that from there, we as mathematicians should use something important. It doesn't mean that this topic is all about stories or information, because I know for the mathematicians, you expect to solve problems and whatever. This is just still introduction. We are building the foundations. We want our students to understand, because when we teach you these ones, you understand, and then it will be a gate for you to understand the next lectures. Later on, for example, the lecture 3, we just have descriptions part, and then we have mathematics, the Booleans or the logical mathematics part. Remember that we'll be dealing with logic mathematics or logical mathematics in this context. We won't have arithmetic mathematics as you think. We are going to have logical mathematics, right? So in lecture 2, we'll be focusing in logical mathematics, and even lecture 3 will be focused onwards. So this is just we introducing to you, and this is the foundation for the entire topic of types of numbers, because we'll be doing too much of conversions. So in any case of conversion, we just teach you the steps to do the conversion. After we taught you all the 4 types of number system, then from there we just do also examples. So you say that if for this case, there is the concept. For this case, there is the concept of what? For this case, there is the concept of significance. Significance. The same value. Significance, the same value. So the 2 sevens in example above don't have the same value. For this case, there is the concept of what? Of significance. So for that case now, let us end the concepts of decimal number system with teaching. The way I'm teaching you this topic of number system might be different from how your class teachers are teaching you, right? By being completely different, because we are all teachers, but we are being guided by NATE, National Council for Technical Education in Tanzania. So I'm using the curriculums that NATE asked us to use, and also sometimes I can use the institutional, so I go through the institutional or the college curriculums and the syllabus which they submitted to NACTE, but the way of teaching from different teachers might be different, right? And the techniques are different, the teaching aids are different, the methodology of teaching might be different, right? So don't try to compare me with your class teachers. But one thing which I want to tell you that is, remember that Olenjolai does not know everything about number system. I just know small portions of it. So if that's the case, I want to tell you in advance, don't ignore the contents will be given by your class teachers. I know small portions of it, possibly that I might be teaching you a certain concept, maybe in a hard way, while your teacher know the simple way or the simple trick for you to comprehend that particular concept. So I really insist, regardless of this supplement program of Online Diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, it does not omit for students to go to class. It does not make students to maybe to ignore their class teachers that have been paying the tuition fee for them to teach them. You have to take considerations of them. So you have to take the bread that they are going to feed you and combine with this bread that I'm going to feed you. I want to tell you that you will be extraordinary students and will be an A students rather than being an F students for the rest of your life. All right? Okay. So significance. So we have something we call this significance. 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 Right? Significance. So I say that every number system or each type of number system has two significance digits. Significance digits. So each type of number system has two significance digits. So this one we can call it most significant digit and the most significant digit and least significant digit. So the decimal number system, because we are focusing on that, the decimal number system has two types of significance, which are most significant most significant digit most significant digit, which in abbreviation is MSB, and the second one we call it least significant digit. In binary also we have two types. We have most significant digit and least significant digit. So a dot and least. So we have most significant digit and least significant digit. Least significant digit. So in decimal number system, we have two types of significance, which are most significant digit and least significant digit. These are very important because later on you will see how to use this in converting one number system into the other number system. So example of least and most significant bit in a particular number. For example, we have 84, 30, 35, like this. And then we have our radix, which is base 10, like this. So you can analyze this number. So what is this? So this is decimal number. Why do we know it's decimal number? Because it's base. And this we call it, my dear student, radix. So now the least significant digit is found on the most right side. It means the first digit on the right hand side of the decimal number is called the least significant digit. So this one is called we call it the least significant digit. Then the most significant digit will be the first digit from left hand side of the decimal number. So my dear student, this is what we call it in logical mathematics as what most significant digit. Right? Can I give you some more example? Okay, so let us take, we have 999. Then we have 8, 7, 6, 5, 2, like this, right? So we can put our radix 10. So what is this? This is decimal number. It's one of the decimal number, right? What is this? This we call it radix, right? And what is this? This we call it most significant digit. And then what is this? This we call it least significant digit. The first number on the right hand side is least significant digit, and the first number on the left hand side is most significant digit. And this is a decimal number. This is radix of 10. So those are the two examples. So this is example 1, and this is example number 2. So I believe that you've understood about significance. Before I teach you about binary number system, which actually that I won't spend much of the time because I've been building the foundations of it. I'll be focusing on its definition. Then I'll be focusing about the significance because all the radix, we have spoken about radix, the examples, and then we end up lecture 1. So I have some few questions that I would like to ask you before I continue further in this lecture. The first question is this: did you understand the meaning of number system? Did you understand the meaning of decimal number system? Did you understand the examples of decimal number system? Did you understand the meaning of radix or the concepts of radix? Did you understand the concept of positions of a digit of decimal number? Positions of a digit in decimal number? Did you understand the concepts of significance? Did you understand about least significant digit and most significant digit? So the answer I would like to ask you, and I would like you to take your time and answer all those questions and send your answers to me through the comment sections. I don't think if you'll spend even more than 3 minutes, because the answer might be yes, thank you, sir. Yes, thank you, sir. I understood this and this and this. You can just write a question there. Yes, after you ask me that did I understand the concepts of radix, then the answer yes, I understood. Thank you, sir. So just like that once, just write that second of the phrase because we want to get feedback from our students. We are teaching an MTech class, but we are teaching millions of ordinary diploma students by face who are there waiting these contents online. Okay? So make sure that you do it. But if you didn't understand, don't lie. Don't give me the answer of yes in order to lie to God and lie to me in order to give me courage, because if you say I didn't understand, it means that I'll be discouraged. No. by God's grace, this is my 13 years of teaching advanced secondary students, ordinary secondary students, ordinary diploma students, and undergraduate or bachelor degree students in engineering and science. So it means that I've faced so many challenges for students not to understand, and always I'm calm and I'm happy to hear about that, because God always gives me another technique to explain the same concept in different dimension in order to help every student to understand. So I'm expecting that you'll be faithful and trustworthy in your comments, in your writing your comments, right? So I'm happy to meet you in that comment section. If the answer of all those questions is yes, allow me right now, ladies and gentlemen, to introduce to you the concepts of binary number system. Ladies and gentlemen, get ready to welcome the new concept of binary number system. Again, remember that we need to use original scientific calculator in this topic, right? Or in this subject or in this model of algebra. So in case you don't have an original scientific calculator, you should not worry. Just the order, it means send to us your order, and then just order it through this telephone number, send an SMS that I want to order original scientific calculator of Casio function 981, and then we can ship it to you, and we can make a call to you in order to give you details about that. Well, so right now, ladies and gentlemen, get ready to welcome binary number system. So this is the second type of number system, binary number system. What am I going to do? Binary number system. And once we have finished this concept, it will be the end of lecture 1. You have to get prepared for the lecture 2, right? The binary number system. The binary number system. So we have the fundamental question of Olenjolai whenever he teaches you about the new concept. And this for today's will be question 4 in this lecture. What is binary number system? First of all, what is binary? What is binary number system? 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 Okay, so we say that in mathematics, and the digital electronics, because we learn these concepts in mathematics and digital electronics, a binary number. What's the binary number? A binary number simply is what? Is a number expressed in the base 2 numeral system. So simply that we say that in mathematics and digital electronics, a binary number is a number expressed. It can be a number expressed in the base 2 numeral system of what? It means that numeral system in terms of what? In terms of 1 and 0. are the first definitions of binary number system. So a binary number means that a binary number is a number expressed in the base 2 numerical system or numeral system in terms of 1 and 0. Or binary number system is a type of number system in which a number is expressed in base 2 in terms of 1 and 0, or in terms of negative 1 and what? And 0. Some other resources also define binary number in this way. So, the binary number system binary number system is a system that is used in the binary number system is a system the binary number system is a system that is used so it's a system that uses only two binary digits. Only two binary digits. Only two binary digits. So uses only two binary digits, 1 and 0, to represent number. So this is the second definition. So either of the definition may be used effectively in any context that you've been asked. So for the first definition, in mathematics and digital electronics, a binary number is a number expressed in base 2. So first of all, it's expressed in base 2 numeral system in terms of 1 and 0. In the second definition, the binary number system is a system that uses only two binary digits. And these two binary digits are 1 and only two binary digits, 1 and 0, to represent 20 numbers. So because you have two digits, then the base will be 2. If you have 10 digits, then the base will be 10. If you have 8 digits, then the base will be 8. If you have 12 digits, or if you represent a number by using any of the 12 digits, then the base will be 12. The base will be what? Will be 12. Okay? So that's the piece of information. So I would like to focus on few information about binary number system, which is very important for you. So at the definition that this number system has only two digits, 1 and 0. 1 and 0. 1 and 0. So this number system is only two digits, 1 and 0. only 2 digits, 1 and 0. It is also a positional number system. It is also a positional number system. So it means that the value of each digit depends on the position of the digit that it occupies. It is also a positional number system. So this means the value of any digit, it means that the value of any digit in decimal, in binary number system, depend on its position. Depends on its position. That depends on its position that digit occupies. This is very important. That digit what it occupies. So example, we can have this example. 1 0 0 1, then 0 1, then 1. Then we have what is base 2. Okay, base 2. So it means that the value of this one is not equal to the value of this one, is not equal to the value of this one, is not equal to the value of this one. So these ones have different values due to their position. Then the value of this 0 is not the same with the value of this 0. It's not the same of this 0 because they have different position. At the point I want to make, I believe that you have understood the same concept that I've taught you in decimal number system. So it says the radix. What the radix of binary number? Radix of binary number. So the radix of a binary number is what? Is 2. So if that's the case now, let me give you some examples of binary number so you might know. But because I've taught you can pause a video and try to write some examples of binary number. Any examples of binary numbers in any arrangement regardless of their values. So examples of binary number so examples of binary numbers can have a binary number of this 112, 012, can have a binary number 00 base 2, can have a binary number 1 base 2, can have a binary number 0 base 2. So we write the radix also as a subscript of a number. Can have a binary number 10 base 2, can have a binary number 001 base 2, and have also a binary number 01. Did you write 01? Yes, I have 01. Can also have a binary number. It's quite different from decimal number because the 0 on the right hand side in most cases, okay, it has also the values, but in case of decimal places of the table. So for this one, 10 has a meaning, and also you can have a binary number even among strings of binary number. and have also a binary. This is comma, all of these are comma. 101 base 2. Can have also another binary number 100011 base 2. Can also have a binary number which only have zeros, maybe 5 zeros. And also you can have a binary number which have only ones, string of ones. And have a binary number which maybe you can have, yes, this is common now, 00, let's say 000111. So 8 bits. You have also a binary number, very interesting, 01, 01, 01, 01, there's 2. Wonderful. And have also a binary number 10, 10, 10, 10, there's 2. Right? Then we can have another binary number, which is very interesting, 0, 0, 0, 1, 1, 0. We'll find these are the common binary numbers that we'll find them 1, 1. There's 2. You can also have another binary number, which is very interesting also, which is 0, 0, and then 0, 1, 1, 1, then 0, 0. There's 2. So how many bits? Okay, 8 bits. So you can have also another string of binary number. These are the 8 bits. So you can have 0, 0, 0, 0, 0, 0, 0, 0. There's 2. So etc. etc. Another point we have seen in decimal number system that you can write a decimal number system without its radix. So not also a binary number system can be written without its radix. Because as we mentioned at the binary number, you should keep in your mind that the radix of binary number is 2. So not before. Like decimal number, the binary number can be written without showing its radix. Without showing its radix. So without showing its radix. I want you to understand. So tell your neighbor, understanding is coming. Tell again your neighbor, understanding is coming. I don't want you to cram. Firstly, myself, your teacher, Olenjolai, does not know how to cram. So I've been struggling too much on understanding every concept, including number system. Remember that I met number system for the first time when I was in my first year of undergraduate studies, or undergraduate, when I say undergraduate, it means degree, it means my first year of my first degree studies in electronics and telecommunication engineering. And you now, as a student of NT level 4, means the first year ordinary diploma students, the good news is this: you met the concepts of number system at Mr. T earlier than myself, right? You met the concepts of number system or binary number earlier than myself. So you have to make sure that you understand, you apply, and even you understand more than I do. Because myself, I was late to learn for the first time the concepts of number system. So for you, you learned it at early stage. So you have to make sure that you understand, and even you'll be a teacher of your children and children's of your children, and the children's of your children's, and the children's of your children's, means on the grandchildren's. You'll teach them about number system, right? So if that's the case, let me give you examples of that, not before, that you can write all of those binary numbers without showing the radix. So example, the first binary number is 101, so you can write it without having base 2. The next one, no, it's 11. So here it is 11 base 2, so we can write 11 without having base 2. Then so you can write what is 01 without having base 2. Then we can write 00 without having base 2. Then we can have 1 without having base 2. Then we can have what 0 without having base 2. Then we have what 1 0 1 without having base 2. Then we can have what is 0 0 1 without having base 2. Then we have 1 0 without having base 2. Then we have what 0 0 1 1 without having base 2. Then we have 1 1 0 0 1 without having base 2. Then we have what 1 0 0 0 1 1 without having base 2. Then we can have 6 how many bits? 5 bits 0 0 0 so having base 2. Then you can write what 1 1. I want you to understand and not to claim. So today I've learned about binary number 1 2 3 4 5 6 7 8. So 8 bits. So 1 this not writing base 2. Then you have 4 zeros and the 4 ones not having base 2. Then you have what now alternatively bits 0 1 0 1 0 1 0 1. Then again the next one we have 1 0 1 0 1 0 1 0. Alright? Then we can have what 1 0 1 0 1 0 1 0. So you have 0 1 0 0 1 1 0 0 1 1. And then so you have what? You have 0 0 0 1 1 1 0 0. So writing space. Then we have what? We have 8 bits of 0. We have 8 0 0 0 0 etc. Did you understand the examples of binary number? Did you understand how to write binary numbers with the radix of 2? Did you understand how to write binary numbers without the radix? Let me know in the comment sections. Please give me feedback and tell your neighbor understanding is coming. Understanding is coming. Okay, I know this is tough. Sometimes if you met them in a different approach, they confuse you. But we are here to redeem you. God is here to redeem you, right? I am his embassy, or I am his servant. So give all the glory and honor for your understanding and comprehension in this session to Almighty God, the God of gods, the King of kings, the Father of the fathers, the Father, our Father, right? The Lord of the lords. So give him all the glory. For me, I give him all the glory and honor because even myself, I didn't learn number system in this style that I'm teaching. This is the new level, right? Even myself, I'm learning in a very simplified way. Wonderful. So those are the examples of 40 of number system, of binary number. But now let us talk a little bit about a terminology that we call it bit. We have a terminology that we call it bit, or in lowercase we call it bit. This is very important terminology in binary language. You hear that these are the 4 bits. These are 10 bits. Okay, these are 20 bits. Okay, these are 8 bits. These are 16 bits, etc. So we have a term called the bit. Say with me, bit. What the meaning of a bit? So bit is very important terminology in this. So I think that I should leave the homework here. Homework. So this is homework for lecture 1. Then this will be question 5. What the meaning? What is bit? What is bit in binary number system? What does the word bit means? but I will explain to you where do we get it. So here it is. So you define, so just leave the space for you to define, at least define 2 definitions, because I encourage students to find 2 definitions because it will expand your understanding. Whenever you learn a new terminology, this is the trick I use for self-learning, right? I thank God. Almost more than 50% of what I know, I've been educating myself. Actually, God has been educating me by going through or reading for the first time, second time, third time, myself, without a physical teacher, right? So that's wonderful and powerful. So you say that, So you say that each binary digit, each binary digit, or each digit that we find in binary number system, right, is called a bit. So this is very important. After define, then so come into this sentence. It's called a bit. It's called what? A bit. It's called a bit. Okay? It's called what? A bit. The word bit is contracted. So it's contracted from 2 words. From 2 words. It's contracted from 2 words. So it's contracted what? It's contracted from 2 words. Binary. So this is the binary digit. It's very important, binary digit. So simply it means that the word bit, this is contracted from the word by, we get it from the word binary, by stands for binary, and then digit, the last letter of the word digit is what forming a T. So bit means binary digit. So it means bit is abbreviation of binary digit. So bit is abbreviations of binary digit. Wonderful. I believe that you understand clearly the concepts of binary number for the rest of your life. Well, so again we talk about significance of 40 of decimal number system. So let us end this session, this lecture 1, with that concept of significance of binary number. So a binary number has 2 significance. A binary number has 2 significance, has 2 types of significance. significance due to the year position. Due to the year position in binary stream. In binary stream. So we have the least significant bit and the least significant bit. The year positions in binary stream. Okay, depends on the year positions in binary stream. So these are one, the most significant bit, which is MSB, and the second one is the least significant bit, which is least significant bit. So the most significant bit and the least significant bit. The most significant bit and least significant bit. Okay? So the most significant bit is the leftmost bit. So we say that the most significant bit is the rightmost bit. Is the rightmost bit, and the least significant bit is the leftmost bit. Okay, so it means that we have the rightmost bit and leftmost bit. Okay, so you have the most significant bit and least significant bit, and these significant bits are very important in conversion of binary number, of decimal number into binary number, or octal number into binary number, or hexadecimal number into binary number. Very important. They will be mentioning them in different cases. Even just converting the fractional decimal number into the fractional binary number, we'll be using this concept of most significant bit and least significant bit. Alright? So example that will show this is this. For example, if you have 1, 0, 1, 1. Let me check just a real example. Example 12 in binary number. 12, number 12, and decimal number 12 in binary number represented as 1, 1, 0, 0. So what the radix of binary number is 2. Radix of binary number is 2. Okay, so here we have 2. So what is this? This is what we call the binary number. It's what we call it binary number. What is this? This is what we call the radix of a binary number, right? And then the leftmost, what are these? These we call them bits. How many bits are there? 4 bits, right? So for this one, it means you have what? 4 bits of information. Then this is the rightmost bit, this is the leftmost bit. So this bit, we call it most significant bit, the first bit, right, from right hand side. Then the last bit from right towards left, this one, 0, bit 0. We call it least significant bit. So those are the 5 pieces of information. We had also 5 pieces of information in decimal number, because for the example that we gave you, for the first example, we had 7 digits. There we call them digits, but here we call them bits. Okay? Okay, so if that's the case, then let me give you another example of what? Another example of 987. Another example of 987. And then analyze. So this is the first example. So this is the example 1. Then example 2 is this. So here we have 1, 1, 1, 1. Here's 0, 1, 1, bit 0. Then bit 1, 1. Here it's base 2. Or you can, okay, you can write with base or you cannot write with base. Just I want to show every concept that I've been teaching you in this. So this is the binary number of this is the binary number which corresponds with a decimal number 987. 980. So if you convert 987, which I'll teach you in lecture 2, the next lecture 2, then you get this binary number, right? So this is what we call it binary. A binary, because it's singular, a binary number. And then what is this? This we call it what? Brackets of a binary number. Where the rightmost bit. What are the names of these 1s and 0? We call them bits, right? First bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, eighth bit, ninth bit, 10th bit. So this is 10 bits of information. You used to have a memory, maybe a memory card, or maybe the size of the video file or audio file of maybe 20 kilobytes, 20 KB, or 100 MBs, or 1 GB. That is the language of binary number, right? Later on, I will teach you how you can convert MBs into KBs, KB into bits, right? And then means that KB into bits, and and then GB into GB into terabytes, or terabytes into GB, or terabytes into MBs. That is. So whenever you heard about that, such kind of the language, is where we are building the foundations. Actually, we are going there, but here we are building the foundation for you to comprehend all of this information. So here we have what? Least significant bit. And this one, so this one, the rightmost bit, the leftmost bit, this is what we call the most significant bit. So, my dear students, that is all. I would like to invite you in the next lecture, which will be lecture 2, and to be titled as Conversion between Binary and Decimal Number System. Okay, so I have left you 2 questions of writing, 2 questions of homework that you have to do, and submit your homework in the comment section before we meet in the next lecture. So this is the end of lecture 1. It has been kind of long lecture, but that should not confuse you. That's how that is what happens sometimes in the world of basic engineering and scientific mathematics for ordinary diploma students. I would like to invite you in the next lecture, which will be lecture 2, where I will teach you about the concepts of conversion between binary and decimal number, which I believe that right now you know them effectively. So we'll be teaching you how you can convert decimal number into binary number. But the next lecture, which lecture 2, will be focused on converting decimal number into binary number, because we have 2 parts. will be having the integral, how to convert an integral number into a binary number. And then we'll teach you about how you can convert a fractional decimal number into a binary number. All right? So stay tuned and stay focused, because this is the beauty of basic engineering and scientific mathematics. So before you end these sessions, I would like just remind you, in case that you have lost your scientific calculator, or you are a graduate from Form 4, and hence you don't know where you can buy a perfect, I don't call it a perfect, actually an excellent original scientific calculator. Here it's the one that I recommend for every student of mine. It's called the Casio Function 981. If you're in the restaurants, okay, you can find these scientific calculators in different bookstores, or in different stationaries, or in different booksellers. But sometimes the price might be higher than the one we've allocated, because actually we are equipping our students. We want our students not to be limited. And as I told you, this original scientific calculator is very important, because it can support, or it can help you to learn basic engineering, scientific mathematics, and all other engineering modules or courses and scientific modules or courses. The needs are, in case you may use this scientific calculator on solving different computational problems. So this is a very important tool. It's a working tool. You need it to have in your hands every time whenever you learn the beauty of ordinary diploma in engineering and science. You may order this scientific calculator. Simply just send to me a message through this telephone number 0759745331, and just write that I'm an ordinary diploma student, or OOD in abbreviations, and I would like to order original scientific calculator to accompany my studies. Then I will make a call. I will call you regardless of any time. Don't make a call, because whenever that I'm too much occupied to prepare the contents for you. So most of the times that phone number or that my mobile phones is in silent mode, in order to avoid distractions, right? But I will make a call. Just send a message to me. I will make a call and give you too much details, more than the one I provide right now. Lastly, in case you feel from your heart that you would like to offer God your feeling thanksgiving for this program, where you can access these contents anywhere and anytime, then you're warmly welcome. Before you make such kind of decisions, I want to ask you to offer a better offering to our living God, and your eyes should be fixed to Jesus only. Your eyes should be fixed on God. For example, myself, I don't know you, but I know God, who has given a gift of teaching. This is my thanksgiving to Him who has given me a gift of teaching. How about you? Maybe you want to offer your feeling thanksgiving, or your feeling offering of any types of offering. Maybe a festive fruit offering. Maybe your tithes, you hear from your heart, because this is the work that is going to transform all poor students, all just the wealthy students, and all even rich students. So actually it's going to impact the life of poor students who would like to learn these contents, but maybe they cannot pay for it. So you can be a part of a teacher, or a part of transmitter of this message to be distributed in the entire country of Tanzania through your offering of an amount, even of 100 Tanzania shillings, will be accepted with great honor. Maybe 1,000 Tanzania shillings will be accepted with a great honor. But our eyes, my eyes, your eyes should be fixed to our King, right? Who receives our offering. Okay? That's very important. So how can you offer? We have two methods. The first one, you may offer through mobile transaction, and that the same number you may send to me through this telephone number 0759745331. Second method, you may do the bank transaction. So read the descriptions below, click the word written, so the buttons written more to open, and you'll see the bank account, the bank name, and even the bank, just the bank details that you like to have. So you're warmly welcome, and I want to tell you in advance, your feeling thanksgiving of any amount will be used to pay for the running cost of this program. We have a vision of recording more than 600 videos that will be teaching about the beauty of basic engineering mathematics, and basic engineering, basic scientific mathematics for ordinary diploma students in engineering and science in Tanzania and worldwide. So it's very expensive to record even a single video. It's very expensive. It's expensive in time, it's expensive in resources, it's expensive in just in internet. So there's too much expenses, I want to tell you. But I want to tell you, for me, as the founder of Online Diploma Polytechnic Institute of Tanzania, I'm not afraid of those expenses. Why? Because the founder and the sponsor of this program is Almighty God, and my Almighty God is greater than all the expenses that will be used to accomplish this assignment and this mission of digital education in Tanzania. So for me, I'm not afraid, and even yourself, you should be afraid, but accept it to be a part of transmitting this message, because these contents will be accessed by present generations and future generations. Even my children who are still in my wisdom will be accessing and will be using these contents to learn. Okay? So you're warmly welcome, and may God bless you wherever you are. So because we had our Alpha prayer, let us have our Omega prayer just to conclude this lecture 1. Our Father who is in heaven, we say thank you for the greatness of your holy name and for your presence. You taught me, you taught your students. Father, I give you thanks as Psalm 136 verse 1 through 3. You say that give thanks to God because he is well, for your love endures forever in this session. I give thanks to the Lord of the Lords, for your love endures forever in this session. And I give thanks to the God of gods, for your love endures forever in me, in my online students. In Jesus' name, amen. May God bless you and keep you until we meet in lecture 1. Olenjolai loves you so much. Welcome to Tanzania, and then stay connected and stay enjoying the beauty of basic engineering, scientific mathematics. See you at the top on solving small-scale, real-life problems in engineering and science aspect. Okay, how are you everybody who is watching this video? I'm very happy to have you today. My name is Olenjolai, Moko TAYAI single, simply just call me Olenjolai. By God's grace, who has given me a gift of teaching. I love teaching. Teaching is Olenjolai. Olenjolai is teaching. And this is work of my heart for the rest of my life. So I've been teaching. I used to teach. I am teaching, and I will be teaching. So I'm a citizen of the kingdoms of heaven, and I'm a citizen of the United Republic of Tanzania. Today, ladies and gentlemen, I have a good news for you, that we have a testimony to testify to you from one of my students whose name is Benedict Busole, which actually that we met during his higher learning institution or learning periods. And hence, I found him with a particular problem in learning. So I think by God's grace, I have been a solution to him. So today, he has a good news to share with all online undergraduate students pursuing engineering programs and even scientific. It means that all undergraduate scientific students and also all diploma engineering students and all diploma scientific students. So, Mr. Benedict Busole, you are warmly welcome.
Thank you so much.
Okay.
Online people.
So, online community, here it is, Engineer Benedict Busole. Okay, so we are very happy to have you today. You are welcome. The online community, there are thousands and thousands of online undergraduate and diploma students. They are really paying attention to what you are saying to them. I believe that it's going to be a message that will transform their life. So you're only welcome.
Thank you so much. Thank you for having me. So I don't really have a lot to tell you guys. I have really simple things to tell you. The reason why you're watching this is because maybe you're having difficulties in understanding some of the concepts that are being taught at your institution. So one of the things that I can tell you is that I've been there as well. And back then when I was there, I really couldn't know exactly what I was doing, because I was giving up as well. I was saying, it's over. It's over. I'm done. Because maybe it's becoming too difficult. And then I met Mr. Olenjolai. I went into his class. I still couldn't believe if I was going to understand, but at the end of that session, when I left, I found myself I was repeating the same word again, and it's that word, the first time I entered the class, that was nothing but I can remember it was limit. It was a definition of limit. Say definition of limit, proper and improper definition of limit. I can still remember it up to this day because I kept on repeating those. So it is okay not to understand everything, and it is okay not to be sure if you're understanding. But take it from me, because I've been where you are, take it from me. Whatever that Mr. Olenjolai is teaching you here, it's something that you gain from, because he has a really passionate way of teaching something. And even if you're not understanding and you are that far, you can always leave a comment and saying, I didn't understand this and why. And I'm sure I can always get back to you. So yeah, that is how I met Mr. Olenjolai, and that is how he helped me into the my year of studies back at the Director of Technology. If you're in diploma, it means you still have maybe problems. And I believe using these videos of that Mr. Olenjolai is trying to teach those subjects that you are teaching, for example, calculus, you will understand, because I did pass through there. And because you're a diploma, when you're in a degree level, you will already have a solid understanding of what was supposed to be taught to you. And if you're in degree, also you have to understand, if you want to, we also have some videos here regarding advanced courses. And if you did understand that well, I believe also you will understand this even better, because you do not have to give up, you have to keep on going, and it is going to help you. And you have to believe them. If you do not believe me, at least take the proof that I'm here today and I finished my studies. So, good luck.
Okay, so Mr. Usole, thank you very much for your testimony. I really appreciate, I love it, I've been blessed. And even online students, I believe that it's the same. But I just have a few questions to ask you, just to help the online community to understand in detail. Okay, so online Diploma Polytechnic Institute of Tanzania and online undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM, both of them, it's a supplementary institution. It's not a physical institution. Actually, this is an online institution, which actually is in air, in cloud. So a student, online community, they can have this challenge. They have their physical teachers or professors or lecturers in calculus, in complex variables and in differential equation, in advanced calculus, in probability and statistics, right? So now the next questions, or the questions comes to their mind. Why do they need supplementary program that Olenjolai is providing to the Tanzanians and international students?
Because the thing about your teachers at the diploma and degree stage is that they assume a lot of things you have already known, which is not that bad, because that's what they're supposed to do. They assume everything you've done already, but the difference is that Mr. Olenjolai here understands that you do not have always to know everything. There's something the human mind can also forget, and he's here to teach you about those things. And his even way of approaching the subject is different. Okay? He's not rushing to go somewhere. He's here just for you. He's not rushing to go somewhere. Despite other teachers, I know I have 2 hours and I have to be done in those 2 hours. Mr. Olenjolai can keep on going on, even not eating, just so you can understand some of the modules. So, yeah, that is the difference between taking this supplementary. We are not saying you have to skip your classes. No, you can still go. It will help you. But also, this will help you even better. So, don't give up.
Okay, good. I'm very happy with your response. So, Mr. Usole, I still have one more question. How, for yourself, you have been a student who's pursuing engineering mathematics in class, and computer programming in class, and electronics modules in class. And then you say at the same time during weekend and during the evening hour, Olenjolai was teaching you a supplement classes at the Director Institute of Technology, and it is true because I've been doing that. So now, can you tell us who are not in your mind at that time, what the difference once you enjoy to take these 2 classes? How did the Olenjolai's classes transformed you to restore your hope or to get connected to your vision?
The difference is, it's like what I said previously already. Some teachers assume already everything you already know. And Mr. Olenjolai knew that some things you do not know already, and he wasn't rushing anywhere. So he took his time in teaching you. And that is what helped me really in changing the way I was approaching this subject. And also he inserted into us that that spirit that you even learned since you were doing A level, that spirit of repeating, doing a lot of questions, okay? Doing a lot of different questions, you see, and it helps you a lot. So that is how Mr. Olenjolai really helped me in his way of taking time into making you understand exactly what you are supposed to.
Yeah, okay, thank you very much. So I still have one last question to end up this testimony. Were you taking supplementary classes from Olenjolai yourself, or you had also some other colleagues?
We are lots. At some point, we are even 50 to 60 people in one class.
In one class.
Yes.
So once the session, or once Olenjolai has finished it to teach you maybe on Saturday, 7 hours or 8 hours consecutively, then what did you hear from your colleagues concerning about the contents you have been given in class? From
everyone was enjoying the class. Everyone was understanding. Because that's why I told you, the teachers, our teachers were assuming you were knowing everything, but Mr. Olenjolai was taking his time. Yeah,
so real means that I would like to say that my classes have satisfied your need.
Yes.
So it means demand has met with actual supply.
Yeah, that's right.
Okay, so thank you very much. So our online community, so let us clap our hands for our friend Sole. Yeah. Thank you very much, my dear students.
You're welcome, people. You're welcome.
Yeah. So this is the community of engineers. Myself, also my professional, I'm an electronics and telecommunication engineer, and this is the computer engineer. So we know what we are talking actually, and we know the responsibility that we have for this nation. So our online community, thank you very much. I know even yourself that you have so many questions concerning about him, or you have so many questions to Mr. Busole. He's a member, so actually he has subscribed into our channel. Remember to subscribe into our channel in order for you to get more updates. So ask any question concerning about this testimony in the comment section of this video, and believe me that I and Busole, and even also as a Olenjolai's alumni at DIT, will give you a quickly response, and actually that will be focusing on enjoying on this content. Right?
So you're welcome.
Yeah, so it means that Busole is ready to wait your questions, and even if you've given up, as he said, that you can just contact him there, and then he can just encourage you, because right now he's a graduate. He's a graduate engineer, right? So because he's a graduate engineer, he passed through the difficulties, even the great difficulties that he has been passing, but he has never gave up. He just looked different alternatives, and finally he made it. So thank you very much, Mr. Busole. You're always welcome next time. Once we need you, we love you so much, and the online community actually
keep on learning.
Will appreciate it.
Yeah.
Okay, see you then. So at the end of our testimony, join me in the next testimony.
Mungu ibariki Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto.